Hello, this is the section 7.4 lesson. In this section we're going to talk about a type of relationship called inversely proportional relationships. Now back in section 7.1 we defined a ratio as a type of relationship between two quantities. The type of relationship that we're going to talk about here in this section at first glance looks very similar to a ratio, and in fact we're going to use very similar tools as working with a ratio, but there's a fundamental difference between a ratio and the type of relationship that we're going to talk about here. So to remind ourselves of what a ratio is, let's look at this example. A muffin recipe calls for 7 cups of flour and 2 cups of milk. If we have 14 cups of flour, how much milk will we need? Well, here in this scenario we have two quantities. We have our cups of flour and we have our cups of milk. And we saw this example back in section 7.1, and we argued that these two quantities form a ratio. And so to solve this problem, we set up a ratio table that looked like this, where we put our first quantity in the first row, our second quantity in the second row, and we put the corresponding values of those quantities, 7 and 2. And so now what we want is 14 cups of flour. And so I say, well, how do I go from 7 to 14? Well, I can do that by multiplying by 2. And with the ratio, if I multiply one quantity by 2, I need to multiply the other quantity by 2. And so there we go. There's our answer. It would take 4 cups of milk to go with 17 cups of flour. So that's how we solved a ratio type problem. Now let's take a step back and make an observation here. So these quantities, cups of flour and cups of milk, form a ratio. Now back in 7.1 we gave that ratio kind of a different name. We also said that those quantities are proportional, or also called directly proportional. These terms, proportional and directly proportional, we'll use synonymous with this term ratio. And the key thing to observe when dealing with a ratio or a directly proportional relationship is that if we double one quantity, the other quantity also doubles. So in this scenario we doubled the amount of flour, and that meant that we had to double the amount of milk. Okay. But now let's look at another type of scenario, or another scenario. So in this one it takes one person 16 hours to mow a field. How long will it take two people to mow the same field? Now we're going to assume that both of these people work at the same rate, and so the people are identical. And so what we have here is two quantities. It looks like we've got the number of people involved and the number of hours. And so it looks like maybe we're dealing with a ratio. So let's try to solve this with a ratio table. So I've got my first quantity, number of people here, my second quantity, number of hours there, and the corresponding values of those quantities. And so now we're dealing with two people. So I say, well, how do I go from a 1 to a 2? Well, I need to multiply by 2. So I might try to multiply the 16 by 2 as well. And if I do that, I would get 32. So this proposed solution here says that it would take two people 32 hours to mow that same field. Well, now I think, well, wait a minute, that doesn't make sense. If I have more people working, it should actually take less time. So that solution doesn't make sense. In other words, we're not dealing with a ratio here, even though it looked like we're dealing with a ratio. It's a little bit different type of scenario. So let's think about how we could solve it. Well, again, we want a 2 here in this row. So to go from a 1 to a 2, we still need to multiply by 2. But now let's think about what we would do down here in this second row. We're not going to multiply by 2 in this case. In this case, we're going to do the opposite. We're going to multiply by a 1/2. And so 16 times 1/2 would be 8. And so there's my answer. It's going to take two people 8 hours to mow this same field. So we've got a different type of scenario here. In this case, I doubled the first quantity, but I actually halved the second quantity. I didn't double it, I halved it. So let's give this type of relationship a name. So in this case, these quantities, the number of people and the number of hours, they're not directly proportional. They are said to be inversely proportional. And what this means in kind of a practical sense is that if we double one quantity, the other quantity is halved. It's not doubled, it's cut in half. So we've got these two types of relationships here. We've got a directly proportional and an inversely proportional. The difference between the two is what happens if you double one quantity. In a directly proportional relationship, you double one quantity, the other one also doubles. In an inversely proportional relationship, if we double one quantity, the other quantity is halved. So let's look at another scenario. Suppose a logging crew of 3 men can clear a tract of forest in 2 days. How many days will it take a crew of 5 to clear the same tract? So let's look at what's going on here. We've got a couple of quantities involved here. We've got our number of men and the number of days that it takes them to clear the tract. So we have these two quantities involved, the number of men and the number of days. Now let's think about, are these quantities directly proportional or inversely proportional? Well, the way we can answer that is to think, well, what would happen if I doubled the number of men? Would that number double the number of days needed to clear the tract, or would it cut that number in half? Well, if we've got more men working and they're all working at the same speed, then it seems like it would take less days. So if we double the number of men, we would actually halve the number of days. And so that tells us that these two quantities are inversely proportional. Okay? If they're not directly proportional, they're inversely proportional. Okay? So once we've recognized that we have an inverse proportionality relationship, we can use that idea to solve our problem. So let's set up a table like this, which at first glance looks like a ratio table, but it's not really a ratio table. We're going to put our number of men there in our first quantity, the number of men in the first row, our second quantity, the number of days in the second row, and then we're going to put the given values of those quantities. We said it took 3 men 2 days. Okay. And so now what we want to get is a 5 up here in this first row. So let's write kind of a 5 over here. And so we think, well, how can I go from a 3 to a 5? Well, it's kind of hard to go directly from a 3 to a 5. So let's add an intermediate step where we're going to go through 1. So let's think about, how can I go from 3 to 1? Well, I could multiply by 1/3. Okay. Now, what am I going to do the second row? Well, we argued that these two quantities, men and days, are inversely proportional. So whatever I do to one, I got to do kind of the opposite to the other. So if I multiplied this by 1/3, that means I need to multiply by 3 down here. So I do that, that's going to be 6. And so this row tells, or this column tells me it's going to take 1 man 6 days to clear that tract of land. Okay. Now let's go from a 1 to a 5. So I can do that by multiplying by 5. And so in the second row, I don't want to multiply by 5, I want to multiply by the opposite, which would be 1/5. And so I do that arithmetic, and that would be 6/5. And so here's my answer. It's going to take me 6/5 of a day for 5 men to clear this tract of land. So we see that in an inversely proportional relationship, whatever we do to one row, we have to do the opposite to the other row. Now let's look at a slightly different scenario that looks a little more complicated. We have 2 people. It takes 8 hours to mow 5 acres. And so notice that we've got 3 quantities involved here. We've got the number of people working, the number of hours, and the number of acres that they're mowing. And we're going to assume that all people involved here work at the same rate. And so there's 3 quantities involved here. Again, the number of people, the number of hours, and the number of acres. Now let's think about these different pairs of quantities and think about whether they're inversely proportional or directly proportional. Let's consider the number of people and the number of hours. And let's say that the number of acres is fixed. So we're just going to kind of ignore the number of acres for right now. And let's ask ourselves, if we doubled the number of people, how would that affect the number of hours? Would it double the number of hours, or would it cut it in half? Well, with more people, it should take less hours, so it's going to cut the number of hours in half. So that means that these two quantities are inversely proportional. Now let's think about this other pair of quantities, hours and acres. So now we're going to hold the number of people constant, so we're going to kind of ignore that, and think, well, if I doubled the number of hours, what would that do to my number of acres? Would that also double it, or would it cut it in half? Well, if I've got people working longer, they're going to be able to mow more acres. So if we double hours, we're going to double acres. So that means these two quantities are directly proportional. Okay, so we got three quantities here, two different pairs of quantities. One pair is inversely proportional, the other is directly proportional. Now let's ask a question about this scenario and try to solve it. So here's our question. How long will it take 4 people to mow 10 acres? Okay. So to set this up, we're going to draw a table, kind of like our previous example. We're just going to have more rows in this table. We got our first quantity in the first row, second quantity in the second row, third quantity in our last row, and I'm going to leave a blank row here. And in a minute you'll see why I leave a blank row. In this first column we're going to put the given values of these quantities. So initially it took 2 people 8 hours to mow 5 acres, so I put those numbers here. Now in the end I want 4 people and 10 acres, and I want to know how many hours it's going to take. Okay? So I want to get my first row from a 2 to a 4 and my last row from a 5 to a 10. Now we're going to work on these rows one at a time. Let's start off by working with just the top row, and we're going to leave the bottom row the same. So I'm going to put a 5 here, and let's think about, and let's go from a 2 to a 4. So I think, how do I go from a 2 to a 4? Well, I can multiply by 2. Now let's think about what that's going to do to my number of hours. Now we argued that the number of people and the number of hours are inversely proportional. So if I multiply my number of people by 2, I need to do the opposite to the number of hours. So I'm going to multiply by 1/2. And so I'll put a 4 there. So this column tells me that 4 people are going to take 4 hours to mow 5 acres. Okay. So now I've got the number that I want in my top row. Let's work on making this number in the bottom row what I want. So I need to go from a 5 to a 10. So I think, how do I do that? Well, I need to multiply by 2. Now we're going to leave the number here in our top row the same, and the bottom I'm going to multiply by 2. So now I think, what is that going to do to my number of hours? Well, we argued that hours and acres are directly proportional. So if I multiply acres by 2, I need to do the same to the number of hours. So I'm going to multiply by 2 there, and I do that arithmetic, and I get 8. So there we go. There's our answer. This column tells us that it's going to take 4 people 8 hours to mow 10 acres. Now our last example is going to be just a variation of this previous example. Scenarios that we have 3 people, takes 2 days to paint 5 fences. How long will it take 2 people to paint 1 fence? So if we take a step back, notice that we've got 3 quantities involved. We've got the number of people, the number of days, and the number of fences. Now we're going to assume that every person works at the same speed, and we're going to assume that all the fences are the same size. And so again, we've got our 3 quantities involved here. Now let's look at different pairs of quantities and think about whether they're inversely proportional or directly proportional. Let's take the number of people and the number of days. So now we're going to hold the number of fences constant, so we're going to kind of ignore it, and say, well, if I double the number of people, what is that going to do to the number of days? Is it going to double it, or is it going to cut it in half? Well, if I have more people working, it should take them less time, so that means that these quantities are inversely proportional. Now let's think about our second pair of quantities there, days and fences. So now we're going to hold the number of people constant. We're going to kind of ignore that. We ask, if I double the number of days, what's that going to do to the number of fences that we can paint? Well, if we have more days, we should have more fences. So if we double this, we should double that. So that means these quantities are directly proportional. Now let's use a table, kind of like our previous example, to answer our question. And so the question is, how long will it take 2 people to paint 1 fence? So I'm going to set up a similar table to what I had before. Got my 3 quantities here. I've got a blank row. In this first column, I'm going to put the given values of those quantities: 3 days, or 3 people, 2 days, and 5 fences. And so in the end, I want 2 people in my first row, and I want 1 fence in my last row. And the question is, what's the corresponding number of days? Well, let's kind of do this in some steps. So I want to go from a 3 people to a 2 people, and that's kind of difficult to go directly from 3 to a 2. So let's put an intermediate step here. Let's go from 3 people to 1 person, and I'm going to keep the last row constant. Kind of like the previous example, I'm only going to work on 1 row at a time, either the top or the bottom. Change 1 row and I can keep the other row constant. Okay? So to go from a 3 to a 1, how do I do that? Well, we multiply by 1/3. So now I think, what does that do to my number of days? Well, number of people and number of days are inversely proportional. So if I multiply by 3 in the top row, I need or 1/3, I need to multiply by 3 there in the second row. And so 2 times 3 is 6. So this column tells me it's going to take 1 person 6 days to do 5 fences. Okay. Now let's add another column here, and we're going to continue working with just the first row. We've got 1 person in the first row. Let's go to 2 people in the first row, and I'm going to keep my last row constant again. I'm going to go from 1 to 2. Think, how do I do that? Well, I can multiply by 2. So what's that going to do to my second row? Well, they're inversely proportional, so I'm going to multiply by 1/2. So 6 times 1/2 is 3. So this column tells me it's going to take 2 people 3 days to do 5 fences. Okay. So now I've got the number that I want in the top row, so let's start working on the bottom row. So I'm going to add another column here. I want to put a 1 here in the bottom row, and I'm going to keep my top row the same, which is 2. So now I need to go from a 5 to a 1. So I think, how do I do that? Well, I can multiply by 1/5. Now what's that going to do to my second row? Well, we argued that the number of days and the number of fences are directly proportional. So if I multiply this bottom row times 1/5, I need to do the same to the middle row. So I'm going to multiply here by 1/5. And so 3 times 1/5 would be 3/5. And so this column tells me it's going to take 2 people 3/5 of a day to paint 1 fence. And so there's my answer. So that's it for the Section 7.4 lesson. Your assignment before next class period is to read Section 7.4 from the textbook.